All right, let's talk about something that gives even seasoned coders the chills: dynamic programming. But what if I told you it's not really about crazy, complex math? What if it's more about just being clever and kind of lazy by not doing the same work over and over again? Well, by the end of our time here, we're going to tear this topic down from intimidating to totally intuitive.
You've definitely been there, right? You cook up this simple, straightforward solution that seems absolutely perfect. It just makes sense. But then you change one tiny little detail and the whole thing completely blows up in your face. And right there, in that moment of failure, that's exactly why dynamic programming even exists.
So to really get our hands dirty with this idea, we're going to use a classic puzzle, the coin change problem. It is the perfect example to show how the most obvious, gut instinct answer can be dead wrong.
So here's the deal. The goal is super simple. You've got a pile of coins, each with a different value, and a target amount. Your only job is to hit that target using the fewest coins possible. You and I, we do this in our heads at the grocery store without even thinking about it, but how would a computer tackle it?
Okay, so what's the most obvious way to solve this? You'd probably go for what's called a greedy algorithm. All that means is you're always greedy. You grab the biggest coin you can at every step. So for 87 cents with regular US coins, you grab a quarter, then another, then another, then a dime, and finally 2 pennies. That's 6 coins. It's fast, it's simple, and hey, in this case it works perfectly. It gives us the right answer.
And this is where things get really interesting. The greedy method seems foolproof, right? It works so well with currencies we use every day. But here's the million-dollar question. What happens if the coins aren't our friendly, familiar quarters and dimes? What if the system is weird?
Okay, let's try to make change for 20, but this time our coins are worth 3, 8, and 11. The greedy approach says, take the biggest one, so it grabs the 11. Now we need to make 9. It grabs the 8. Now we're left with 1, and whoops, we're stuck. There's no 1-cent coin. The greedy method fails. It says the problem is impossible. But is it? No way. You could just use 1 11 coin and 3 3 coins. That's 4 coins total. And that's the whole point, right? The choice that looked best at the beginning, taking that big 11 coin, actually led us down a dead-end path. We need a smarter strategy.
And this is exactly the kind of puzzle where our hero, dynamic programming, or DP for short, comes in and shines. It's a technique specifically designed to find the truly best solution, especially when a simple greedy approach just won't cut it.
So what the heck is it? Well, at its core, dynamic programming is all about one big idea: solve huge, complex problems by chopping them up into smaller, more manageable pieces. And this is the magic trick, okay? It solves each little piece just once, writes down the answer, and never, ever has to figure out that same little piece again.
I mean, this quote just nails it. It's all about being smart and, honestly, a little lazy. Why do the same work twice if you don't have to? DP is like creating a cheat sheet for yourself as you go along. You solve a small problem, jot down the answer, and then whenever you see that problem again, you just look it up. No need to rethink it.
Okay, but here's the catch. You can't just throw DP at any old problem and expect it to work. For this technique to be the right tool for the job, the problem needs to have 2 very specific qualities. Let's call them the secret ingredients.
First up, it needs optimal substructure. And look, that's just a super fancy way of saying that the absolute best solution to the big problem is built from the absolute best solutions to its smaller parts. In our coin problem, the best way to make change for 20 has to include the best way to make change for all the smaller amounts leading up to it. And second, you need overlapping subproblems. This one's easier. It just means that as you break the problem down, you find yourself needing to solve the exact same little subproblems over and over and over again.
You know, the best way to actually see this overlapping idea in action is with an old classic, the Fibonacci sequence. Remember that one? Where every number is just the sum of the 2 before it. So let's say our big goal is to find the 5th Fibonacci number, Fib 5. Okay, simple enough, right? To get the answer for Fib 5, you just need to know the answers for Fib 4 and Fib 3. But hang on a sec. To get the answer for Fib 4, you need to know Fib 3 and Fib 2. Wait a minute, did you see that? To solve our main problem, we need to calculate Fib 3. But to solve one of the subproblems, we also have to calculate Fib 3. A dumb brute force approach would just do the work twice, but dynamic programming is smart. It calculates Fib 3 the first time, saves the result, and the second time it just says, oh, I know this one, and looks it up instantly.
Okay, so we get the why. But how do we actually do it? Well, when it comes to implementing a DP solution, there are two main ways to go about it. They're called top-down and bottom-up.
Think of them as two different flavors. The top-down approach, also called memoization, is kind of like how we just described Fibonacci. You start with the big, main problem and break it down with recursion, and as you find answers to the smaller problems, you store them in a cache. The other style is bottom-up, or tabulation. This is the reverse. You start with the absolute smallest, easiest problems, solve them first, and then use those answers to literally build your way up to the final solution, usually by filling out a table.
All right, I know what you might be thinking. This sounds super theoretical, right? Like something you'd only see in a textbook or a coding interview. But the truth is, dynamic programming is running quietly in the background of a ton of the tech you use every single day. And I mean, it is everywhere. When Google Maps calculates the fastest way to get you from point A to point B, that's dynamic programming. When your phone's autocorrect figures out what word you were trying to type, that's DP. Vending machines, DNA sequencing, even complex project planning, they all rely on the same core idea of breaking down a massive problem into smaller pieces and building on the best solutions. That's why this stuff actually matters.
So the big question is, how can you start thinking like this? How do you actually get your brain into that DP mindset when you're faced with a tricky problem? Let's build a quick mental roadmap.
Step 1, and this is crucial, just figure out how to solve it the dumb, slow way first, the brute force way. Then, you gotta spot the pattern. How does the answer for a bigger problem depend on the answer to a smaller version of itself? That's your recursive relationship. From there, you just optimize it by adding a cache to store results. That's memoization. And as a final step, you can often convert that recursive solution into a simple loop, making it even faster. And that's tabulation.
Now, as you're getting started, there are a few common tripwires I want you to watch out for. Don't forget the weird edge cases. What if the input is 0 or an empty list? Always double-check your base case. That's the simplest possible problem that stops the whole chain of recursion. And please, remember that the whole point is efficiency. A DP solution that's still too slow isn't really a solution.
And really, that's what it all comes down to. See, dynamic programming, it's not just some fancy algorithm. It's a philosophy. It's a way of thinking that teaches us that even the most massive, overwhelming challenges can be conquered if we just break them down, solve the little parts correctly, and build on our wins. So I'll leave you with this. What's that big, messy, complicated problem in your world that you could start breaking down today?